I'm Matt Swartley with Chariot Solutions, and I would like to introduce you to Yehonathan Sharvit, who is a passionate Clojure programmer and a software architect at Psycognito, where he builds software infrastructure for high-scale data pipelines. Today, Yehonathan is going to share with us his unique perspective on immutable data and persistent data structures. So please welcome Yehonathan Sharvit.
Hello, everybody. I'm happy to be here, joining remotely like all of us. So the title of my talk has changed a bit. It is called The Secret Art of Storytelling in Programming. In other words, how to write code that is fun to read. Let me tell you the story of Dave. Dave is a full-stack JavaScript developer who works at Clafim, a Tel Aviv company that develops an online book search service. Dave is a good JavaScript developer. He masters all the subtleties of the language, like the differences between null and undefined, the quirks of this, as well as the nuances between double equal and triple equal. Dave really loves programming. He follows tech gurus on Twitter, he reads Hacker News every morning, and he regularly attends tech conferences. In short, Dave is passionate about programming, like you and me. Yet, Dave does not enjoy his work at Clafim. Why? Because on a daily basis, he has to work on code that looks like this. Long and boring code, code full of comments and low-level details. This kind of code makes Dave want to hang its author. Except that sometimes the author of the code is none other than Dave himself. How many of you know developers like Dave? How many of you yourselves are Dave? I used to be a Dave until a couple of years ago, I got tired of suffering from this gap between my passion for programming and my burden at work. My name is Yehonathan. I was born in Paris around 40 years ago. When I was a child, I hated reading. I couldn't read more than a few pages of a book without having this feeling of boredom causing me to yawn and close the book and fall asleep. However, I loved stories. I loved listening to the stories my father told me in the car on the way to school in the cold Parisian mornings. My mother, she was going crazy over my inability to read books. She was worried about my schooling. You know, in France in the 90s, reading books was really a big deal. My mother bought me all kinds of books, but nothing helped. Nothing helped. Until the age of 15. What happened when I was 15? Well, I finished my first book. I managed to finish a book for the first time in my life. Woohoo! But it was not a book like the others. It was a choose your own adventure book. You know, those interactive adventure books in which at the end of each page, the reader has to make a choice. Like, for example, choosing between opening a secret door or stepping back. When I told my mother I finished the book, she was over the moon, thinking she had finally found a cure for my aversion to books. But her joy was short-lived. Indeed, apart from this interactive book, I have not managed to read any other book. Unfortunately, my experience with the Choose Your Own Adventure book was not a transformative experience. After completing my high school in France, I came to live in Israel, where I studied engineering at the THEOREM in Haifa. For more than 20 years, I have worked as a developer in all kinds of companies with all kinds of programming languages. Languages like C++, Java, JavaScript, Ruby, Python, and Clojure. And no matter what the programming language is, whenever I read long code, I experience the same kind of struggle I had as a child when I tried to read books. The same kind of struggle that Dave experiences at Clafin. I am bored in front of these endless lines of code. And yet, I love programming. I really love programming. Once again, this mysterious gap. Maybe you don't experience the same difficulties as me reading books. Well, I envy you. But let me tell you about the next step of my journey as a developer, because I'm quite sure the struggle I'm going to tell you about will sound familiar to all of you. Indeed, I'm going to talk about contracts. You see, around 5 years ago, I became an independent consultant. And part of my job is to sign contracts with my clients, contracts like this one. For me, reading a contract is a nightmare, literally a nightmare. So many irrelevant details that I have to get through, but I have no choice but reading the entire contract in order to make sure that I have not missed an important piece of information concerning the fee or the conditions of liability. And that bores me even more than reading code. Not you? Today, I'm here to share with you the secret behind these three kinds of struggle. Struggle with books, struggle with code, struggle with contracts. I truly believe it's our responsibility as a community of developers to stop causing suffering to guys like Dave. How? By writing code in such a way that it is fun to read. In order to find how to write code that is fun to read, we need a framework to understand what is causing struggle. And I think it has to do with what psychologists call mind spans. What is a span? The span is an ancient unit of measurement that goes between the tip of your thumb and to the tip of your little finger. It's about 8 inches, around 20 centimeters. And many of the tools that we use on a daily basis are designed in a way that respects the span. Forks, knives, pans, frying pans, handles, door handles, all of them are more or less around 20 centimeters. And if they were more than 20 centimeters, it would be very inconvenient to handle them. And if they were less than 20 centimeters, they won't fit in the span of our hand. In a similar way, psychologists have discovered mind spans. And today, I'm going to illustrate 3 of them. The first one is memory span. And it has to do with the number of items that we can easily handle in our short-term memory. In order to give you a sense of our memory span, we are going to do together 2 tests. Don't worry, no exam at the end. It's more an experiment than a test. So in the first test, I'm going to go over 6 letters, and I am asking you to try and remember the 6 letters. Are you ready? Okay. B, C, Y, T, K, X. Now try to remember the 6 letters. And notice, how does it feel when you try to remind the 6 letters? I assume that it's not too painful, because our short-term memory can easily cope 6 items. Now let's do a similar test, but with 10 letters now. Are you ready? Okay, let's go. H, B, F, K, C, M, T, B, V, X. Okay, now try again to remind yourself the 10 letters. I'm going to give you a few seconds. Assuming that you are not a master of memory, or that you don't have any special training for memory, I can say that it's cumbersome. It requires lots of effort to try to remember the 10 letters. No matter if you do remember or if you don't remember, the point of this test is for you to feel that when we want to keep in our short-term memory more than 7 items, it's painful, it's difficult. Our mind is not designed for that. In short, psychologists have discovered that the size of our memory span is around 7 items. Phone numbers are around 7 decimals. License plates in many countries are around 7 decimals, and usually we can remind them in our short-term memory. The second span I'd like to talk about is called the attention span. And it has to do with how our level of attention evolves over time. For how long can we stay focused on a task, on a homework, listening to a conference, reading a book, etc. Psychologists have discovered that our level of attention has this kind of curve. At the beginning, in what they call the zone of primacy, our attention level is low. And after some time, we get into the zone of where it's very difficult to stay focused and to keep our level of attention. And at the end of the session, when we know that the talk is going to end in about 5 minutes, we have another peak of attention, what is called the zone of recency. Some self-management techniques leverage this information. There is one technique that I like a lot called the Pomodoro technique. Pomodoro comes from the Italian word pomodoro, which means tomato. And it has to do with this device that we used to have in our kitchens, mechanical device to measure time. And the Pomodoro technique is extremely simple. Let's say you need to prepare an exam, and you assume that it's going to take you around 4 hours. You need around 4 hours of work for preparing the exam. So instead of learning your material and doing homework for 4 hours, you split the 4 hours in bunches of 30 minutes. And because 30 minutes is more or less the time we can easily stay focused according to the attention span. And after each 30 minutes, you take a brief pause and you come back again to your homework or to your exam session. And the good news is that when you start a new session, you start another zone of primacy and you are able to focus again. So focusing 8 times 30 minutes is much easier than focusing 1 time 4 hours. The last span I'd like to mention is what I call the structure span. And it has to do with how we organize things so that we can reason about them. For example, in an enterprise, the standard way to organize the work between people is to have people inside teams. For example, the CEO would manage a team of vice presidents, and each VP would manage a team of team leaders, and each team leader would have a team of developers and QA members. And more or less, that's how many organizations work. In the agile world, maybe it's a bit different, a bit more flat. But the traditional way of organizing people at work is a structural way. What I'd like you to notice in this diagram is that usually different members of the same team share similar responsibilities. It could be a developer and a QA, a developer and another developer, a VP and a VP. It won't make sense for a CEO, for example, to manage both a VP and a developer. It will be very difficult to manage this different level of abstraction. Usually, it's easier to have a tree structure where the information flows from top to bottom in terms of what and how. So the CEO defined the what, it is translated by the VP as the how, and the how becomes the what of the layer below, down the tree. So let's quickly summarize the 3 mind spans we have discussed. First span is the memory span, which is about more or less 7 items. The second span is the attention span, around between 25 and 30 minutes. And the third span is the structure span, where it's easier to manage a structure where we differentiate clearly between the what and the how. The word span might be the origin of the HTML span element. I don't know, maybe. So we are about 20 minutes in this presentation. And according to the attention span, your attention level is starting to go down. So in order to reset our mind, our level of attention, I'm going to tell you a joke. Are you ready? 1, 2, 3. Okay, actually there is no joke. I don't need to tell you a joke in order to reset your attention level. I've tricked your mind in such a way that now we are going to start a new session of attention, and hopefully you will be awake for the next 20 minutes of the presentation. Let's see how the SPAN framework helps to understand the struggle I had as a child to read books, and why interactive books make it easier for me to read them. So let's say I needed to read a 100-page book. For me, a 100-page was a lot. I had to start a chapter without knowing exactly when it's going to end, and it seemed like an infinite journey. So I would surrender after a few pages. While in interactive books, the fact that at the end of each page, I, as a reader, had to make a choice this kind of choice I made was like a reboot to my attention span. And in fact, my experience was that instead of having to read 100 pages, I needed to read 100 times one page. And it's similar to the Pomodoro technique. Instead of studying for 4 hours, which is difficult, we can study 8 times half an hour. Contracts. The kind of contracts I shared with you before definitely does not respect structure span. There is an interplay of what and how, of high-level details, low-level details. The structure is not clear. You don't know what information is important, what information is skippable. It's a mess in terms of structure span. Contracts are definitely hard to read, unless you're a lawyer. And maybe that's the purpose of lawyers, to make them difficult to read on purpose. I don't know. Let's see now how the span framework helps to understand why traditional code, like the code that Dave struggles with, why it is struggling, why it is boring to read code like that. So let's go back to Clafim and the handle search query. And let me give you an example of how this code could be used. I told you that Clafim was in the business of online book search. So here is the description of a query. In that case, we want the match to be not according to whole word. And we want to retrieve only the title and the author field of each book. And we want to sort the book by publication year in a descendant order. And here is a summary of our catalog. And when we call handle search query with the catalog and the what WAT query, here is the result we get. We get 2 books, Water for Elephants by Sarah Gruen and Watchmen by Alan Moore. So now let me show you 5 reasons why this code is boring. First of all, it's long. 30 lines of code, including comments, is a lot. When I read code like that, when I get around line 11 or 12, I forget what I read in line 1 and 2. My memory span is not taken into consideration. Moreover, because the code is so long, the author needed to write comments. But the comments are in the way of the information flowing of my reading experience. I have to read prose and code and move back and forth between code reading and English reading. And it makes things harder to read, at least for me. Number 3, the what is mixed with the how. Let me show you an example. Filter is a high-level function that deals with the what. What filter does, it receives a collection and returns elements that match a predicate. But the predicate is expressed in terms of a very low-level construct, a regular expression. And the same for map. It's a high-level function, and here it is intertwined with low-level function like string capitalization. The fact that the what is mixed with the how make it harder for us to read code like that. Once you look carefully at this code, and it takes time, you see that in fact the code is well written. There is a flow in the code. First, we search the books, then we enrich them, then we sort them, and finally we pick some fields. So the flow is quite clear. It's a linear flow. It's a very simple data pipeline. But the tragedy is that this simple pipeline is not expressed in the structure of the code. The only way for me to discover this nice flow is to read each line of this boring function, and it takes time. So the flow is not clear. The flow is not explicit. In a similar way, if you look at the code between line 18 and 21, you will discover, this is the piece of the code that deals with the sort. You will discover that the sort is influenced only by the enriched books retrieved from the previous step and the sorting options retrieved for the options argument. And the output of this code is the sorted books that is passed to the next step. So this code is modular. The code is beautiful, but the structure of the, the scope of the code, what are the arguments and the variables that influence the lines, the code between lines 18 and 21 is not explicit. The scope is unclear. So here is the summary. Here is what the MindSpan framework allows us to understand. Boring code usually challenges MindSpan in terms of memory. The functions are very long. In terms of attention, the flow is unclear. The scope is unclear. And in terms of structure, the what is mixed with the how, and we have comments in the way interleaved with code. This is what makes our code boring and not fun to read. What can we do with that? Are we forced to program this way? Are we condemned to write code in this way? I believe that the answer is no. There is a way to write code that is fun to read. And for that, we need two insights. Number one, we need to be aware that it's important to write code that is readable. There is this great quote from Structure and Interpretation of Computer Programs that goes like that. It's quite provocative. It was written in the 80s. It's quite provocative. It says, programs must be written for people to read and only incidentally for machines to execute. It's much more important for a program to be easily read by my colleagues than it is important for a program to be executable by the machine. And I believe that in the cloud era in 2022, it's even more true. Because writing code that does the job, usually it's quite easy. We have so many languages, so many frameworks, so many libraries. So the challenge is not how to get the first version of the code to do the job. The challenge is how to write code so that it conveys clearly the ideas. It conveys clearly the intent so that our colleagues will be able to maintain this code. The second insight I got comes from this beautiful book by Rob Martin called Clean Code, and especially chapter 3, where the author shares a couple of insights about how to write code, how to write functions that are fun to read, that are easy to read. And I'm going to elaborate on chapter 3. In a humoristic way, I would say that this is the fundamental theorem of code writing. It goes like that. Code that is written with respect to our mind spans is fun to read. This is the fundamental theorem of code writing. But please do me a favor. Do not Google this term, fundamental theorem of code writing. You will find nothing. Let's see what it takes. We need to follow 3 guidelines, and in return, we will get 3 great benefits. Guideline number 1, we should write small functions. Instead of the 30-line handle search query, we can make it a 4-line function. Just like this. All I had to do is to take each step of the pipeline and refactor it into a small function. Number 2, each and every function, the body of a function, should be made by statements and expressions that belong to the same level of abstraction. The same level of what, or the same level of how. No more mixing between filter and regular expression. if I need a regular expression to match a query, I'm going to wrap the regular expression into a function called match query. And now I can read this code in terms of the what searchbooks does, what does searchbooks function do. It filtered the book according to a predicate called match query. And if I care about the implementation of match query, I can navigate to the implementation of match query. And if I don't care, I can just skip. The last guideline, the third guideline, has to do with descriptive names. No more comments. When each piece of code or each step of the algorithm is wrapped into a function that has a descriptive name, I don't need to write a comment that say, this piece of code sorts books. The name is descriptive of the behavior of the function. I need comments in my code only when there are surprises, only to explain why I decided to implement this way, but not to convey my intent. The intent should be conveyed by the name of the function. And if I follow those three guidelines, I gain three great benefits. Benefit number one, the flow is clear. The flow is explicit. Look at that. Handle search query. You don't need a PhD in programming in order to understand that search query returns books, books are passed to enriched books, enriched books are passed to sort books, and sorted books are passed to select booked fields. The flow of the algorithm is conveyed is expressed clearly in the structure of the code. Benefit number two, the scope of each piece of code is clear because every couple of lines are aggregated into a function and the function has a clear scope. The behavior of the function is influenced only by the argument the function receives. I'm putting aside the question of global variables. I'm assuming now that we don't have any global variable. So the scope is clearly expressed in the structure of the code. Finally, as a reader, I can read the code in an interactive manner. For example, let's say I want to understand how the sorting order, whether it's descending or ascending, is handled by sort books. So I'm reading the sort books function. And here I see that the first piece deals with the sort and the second piece deals with the maybe reverse. So I can skip the piece about sort by fields. I can step over like a debugger and step in the implementation of maybe reverse. I don't have to read many lines that deal with sort by field. I have clear cues about what pieces I can skip and what pieces I can step into. In a similar way to this kind of code respects my attention span in a similar way, like interactive books respected my attention child when I was a child. Let's see how it looks like for real. So here I have refactored the handle search query, the 30 lines, into a tree of function calls. Please follow me and look how short and clear is the handle search query now. And let's say, so it's made of 3 lines, search books, enrich books, and format books. And let's say I want to understand how the enrichment piece works. So I can I can skip search books and dive into the implementation of enriched books. And the enriched books is made of a mapping function, and author name. So I'm going to step into author name. Actually, let's take a different example. Let's see how search books work. So I'm going to close this and do the same with search books. So let's say I want to understand the implementation of search books. I'm going to step into search books on the left here, on the tree. And now I want to see how the query is matched. So I'm going to step into match query. And now I want to understand how the whole world is managed. So I'm going to step into has word starting with, which is just below here. And I'm done. And here, all the ugly stuff happen, all the lowering case and regular expression. I hope it gives you a sense of how fun it is to interact with code written this way. In summary, the fundamental theorem of code writing says that when we respect our memory span, our attention span, and our structure span, code is fun to read. Why? Because code is made of small functions. Code is interactive. Function names are descriptive. We don't have comments anymore. Each piece of a function deals with the same level of abstraction. The scope is clear and the flow is clear. And believe me, when I read code written in this manner, I'm not bored. I'm excited. My attention level is high. I'm happy. How does it look like in practice? Is it applicable only in JavaScript? The code snippets I've shared here are from JavaScript. And JavaScript, you know, is a very flexible language. It's easy to define functions. It's easy to manipulate data. But would an approach like that be applicable in Python, in Ruby, in Java, in Clojure? I believe that the answer is yes. And it has to do with three great features of JavaScript, or of a taste of JavaScript, of flavor of JavaScript. It is what we call data-oriented programming. In data-oriented programming, we separate between code and data. So we don't have huge objects with state. We have namespaces made of stateless functions that receive data they manipulate as an explicit argument. Moreover, quite often, data is represented only simply as maps. No data classes, no custom types, it's just maps. And finally, in the flavor of JavaScript that I recommend, data is immutable. And why is it important in the context of the code writing approach I'm sharing with you today? Because when code is separated from data, where code resides only in stateless functions, it's very easy to refactor a big function into many small functions. And when you split into a small functions, no matter what the argument of the new function are, you don't have to type the argument. You don't have to pay the price for having refactor into small functions. Finally, when data is immutable, there are no surprise. If you pass an argument to a function, you are guaranteed by the paradigm that the function cannot change the data. So you don't need to read the code of the function to make sure that the function has not mutated your data without being aware of it. So in data-oriented programming, it's very natural to write code that is fun to read. But like all the good things in Earth, don't over abuse it. If you create too many small functions, if every piece of logic is wrapped into a function, you will have a deep tree of function code. And it becomes, you have traded one kind of complexity with another kind of complexity. When you have too many levels of nesting, it's not fun to read code. So don't over abuse it. Moreover, each time you create a new function, you need to find a descriptive name for it. And it puts more effort on the writing side. So sometimes I would just leave a piece of code with as is without wrapping it in a function because I could not find a descriptive name for the function. Finally, in the context of testing, there are pros and cons. On the good side, on the positive side, once you split a big function into small function, you can test each part of the data pipeline. And it's easier to test a small piece of the pipeline than testing the whole pipeline. On the other hand, when you refactor a big function into many small functions, then you get into a problem. And when you write tests for each and every small function, now when you make a change to your code, when you refactor the code once again without changing the behavior of the code, you need to refactor your test. And usually having to refactor test when you refactor code is not a good sign. So don't over abuse this coding style. Finally, the last piece of advice I want to give you is when you come to write code, keep writing code the way you are used to. Keep writing code in the way that is the easiest for you. If it's easier for you to write the code, the implementation of your data pipeline in a flat way, do so. And then refactor into small functions with descriptive names. Let me summarize what we have covered in this presentation. So in order to write fun code, what I call storytelling, we have to understand what are the three mind spans: the memory span, the attention span, and the structure span. And we need to write code in order for our code to be fun to read. We need to respect those three spans. How does it look like? We respect the memory span by writing small functions. We respect the attention span by making our code interactive and allowing the reader to either step in or step over, like a debugger. We use descriptive names, and then we don't need comments. And we respect the structure span by having a single level of abstraction per function. And the flow is clear and the scope is clear. And in practice, it's quite natural to apply it when we use the data-oriented programming paradigm. My advice is to write first the code in the easiest way for you and then to refactor and not over abuse it. Don't have a too deep level of function call. And you save yourself the need to come up with too many names and to test too many functions. Let me conclude this presentation with a few words of hope. I hope that someday, in the near future, books will be refactored in such a way that any child on earth could enjoy and have this great feeling of completing a book, many books, and not only interactive books. It might be a bit too optimistic. So I'm going to say, I hope that in the near future, contracts and agreements will be written in a way that respects mind spans, where I could read here how an agreement would look like. Very short. And if I need to understand what do the two parties of the agreement mean by services, I can click a link and see what is the definition of services. And if I want, and each item of the services is clearly exposed in a short way. And if I need to understand what the two parties mean by expertise, I can link again, like Wikipedia pages. So I hope that in the near future, agreements will be refactored in such a way. But this might also be too optimistic. So let me revise my expectation. And I really hope that in the near future, we, as a community of developers, will refactor our code so that it is fun to read for any developer that loves programming. And by that, we will make the world a better place. Here are the links to the books I mentioned: Clean Code by Robert Martin, Data-Oriented Programming by myself. You can follow me on Twitter or on my blog. And I wanted to mention that most of the illustrations from this presentation have been drawn by my two daughters, Odaya and Adva. If you have questions, I'll be happy to take them.
That was really great, Yehonathan. Thank you very much. So I think there was one question that included a code snippet, so I posted that in the Zoom chat. So do you see
I see
there?
that.
I guess it was closure-related question.
Okay. What is your opinion on doc strings on functions like that? Get all applied data shares, get both incoming and outgoing applied data shares for an org. I appreciate them because sometimes predicates can be confusing as to big picture what they do, that just by looking at the function name. Yes, sometimes it's hard to come with a name that is both short and descriptive, and doc strings can definitely be helpful. But I think that in many cases, we can save the need for doc strings and come with a descriptive name for our functions.
Okay, there's another question from Zoom. Have you looked at Brett Victor's learnable programming, and what do you think of his suggestions?
Which one? Sorry, say it again.
Learnable programming, and it seems to be by Brett Victor.
Oh, yeah. So I'm a big fan
of
Brett Victor. I watched one of his videos from, I think, 10 years ago, where he demonstrated a programming environment that is highly super interactive, where you modify the code and you see it immediately in action. Nowadays, we call that hot reloading, and it's supported somehow in React, and ClojureScript has a great support for it. It's definitely very helpful, but I think it's I would say orthogonal to the topic of this talk, because what I'm talking about here is making code easy to understand in a static environment without having to run the code. Definitely, if you have the ability to run the code in the REPL, in the console, or in the browser, or see what happens when you change something, it's great. But sometimes you cannot afford that. And sometimes you read code to be understandable on its own, just by reading it. So it's two different kinds of improvements to code readability.
Okay, there's another question here regarding what you said about how the portion of the program where the what was mixed with the how. The question is, in regards to that, is the invocation the what while the function implementation the how, or is it something different than that?
Okay, it's a bit different, and I agree that I admit I was not 100% clear. So let me go back to the example. Let me go back to an example. Sorry. Okay, here. Can you see orgpad? Can you see the tree of function calls?
Yep. Yes.
Okay. So let's take a look at this one. Sort books. So here, the way sort books is written is in a way that all the lines in the body of the function deals with the what. And the what from one layer, sorry, the how, no, I'm confused. It only deals with the what. So I could read this function in this way. In order to sort books, we first sort them by field, and then we maybe reverse them. The two lines in these functions share the same level of abstraction. And if I care how maybe reverse works, then I can go one level below and see the how of maybe reverse. But if I had the body of maybe reverse inside the body of sort books, I couldn't phrase it this way. I would say, in order to sort books, I have first to sort by fields. And then if I should reverse, I reverse. And if I don't, I return as is. And you see that here I have mixed, in the second version, I have mixed the how with the what. And how and what is always relative. So at this level, reversing, calling reverse from Lodash is not considered the what, it's the how. Or deciding whether I need to reverse or not is the how. At this level is the what, but at the above level, it's the what. I'm not sure if it's 100% clear. It's like when you give a task to someone, to a team. Let's say I am the CEO, and I say to my team, I want you to build a great product. That's the what. Now the product team will say, okay, what is a great product? Oh, it's a product with a great UI. Let's make a great UI. What is a great UI? Oh, a great UI is a UI that is responsive. So when the information flows down in the hierarchy, the what is splitted into the how, and the how become the what, and the what become the how, etc., etc. Does it make sense?
I think so. And you got a thumbs up from the asker of the question. So I think you did a good job.
If you can rephrase it on Slack, because I really struggled with this piece when I prepared for the presentation. So if one of you guys can send me a proper way to express this idea in Slack, in the Room B channel, I'd really appreciate it. And I will include it in my next presentation. Because the idea is clear in my mind, but for some reason I cannot find simple words to express it.
Okay, yeah, great. We'll continue the discussion on that topic in that Room B channel. We can do that all day today and tomorrow. I guess selfishly, I have a question. So I like everything that you said about the ideas to keep in mind as you're coding. Do you think that there are certain languages that lend itself better to that style, or do you think that with the right discipline and the right willingness that code can be written in this manner in pretty much any language?
Yes. So both are true. I used to say, when I moved from JavaScript to ClojureScript, I used to say that in JavaScript, if you really want, you can write clean code. And in ClojureScript, if you really want, you can write ugly code. So somehow the native idioms of the language take you in a direction. And in Clojure, I think that Clojure, from the languages I'm acquainted with, is the language where this style of programming is the default. Default Clojure code looks like that, but you can write huge functions and intertwine low-level details and high-level concerns in Clojure code. But the language takes you there, and once you have programmed for a couple of years in Clojure, you can easily apply the same coding style in any language. And when I write code in JavaScript, that's how I write it. And I think it's also applicable to object-oriented programming languages like Java or C#.
Okay, thank you for that. All right. Are there any other questions for Yehonathan? We're about 3 minutes from time, so we're getting toward the end here. We have one attendee who says, thanks very much. Now he's got to go back and refactor everything he's ever written.
Mm-hmm. Oh, by the way, I forgot to mention that maybe a question you could ask me, how do I deal with code that is not written like that. Me as a reader, when I need to fix a bug in a code or to add a feature in a code that is not written in this way, because I really struggle. It's not all what I said is true. I really struggle with reading books and with reading long code. So the trick I found is when I can afford it, before I add a feature or make a change to a code that is long, I first refactor it, following this coding style. And then I make the change to the code, only then.
What if there's no tests?
Sorry?
What if there's no test? Do you refactor first or do you write tests first?
That's a great question. It depends. It depends. But this kind of refactoring techniques are very mechanical. So if you follow them, usually it won't break. I mean, if it will either break everything and then you will discover it, or it will work. It's very rare that it will work in only some of the cases. So yeah, it's better if you have a test, but you can write even a single test and it will get you more or less covered.
Okay, so someone mentioned an assembly line analogy. Each station is responsible for the thing they do as the product or data moves between the stations. I think that was a way to maybe attempt to sum up the not mixing the what and the how.
What did you say, the stations?
Each station in an assembly line is responsible for one thing, adding one thing to the product or the data that moves as it moves between. I think it was an attempt to apply the assembly line analogy to the concept of not mixing the what and the how.
Yes, yes. And I shouldn't care about the how. I shouldn't care about the how. I don't need to, in order to understand in an assembly line what a station does, I don't need to take a look into the station. I see how it works by reading the specs. And this works in programming only when you keep your data from being mutated, because otherwise you never know and you cannot trace documentation. So that's why data immutability is crucial here. Otherwise, it's based just on trust and hope.
Hope. Okay, well, I see that we're at time here. So once again, Yehonathan, thank you very much for presenting today, and for everyone that attended. I really appreciate that you're at the conference. Any last words, Yehonathan, before we shut down?
Yes, I would really love to hear from you guys on Twitter and share your stories, your refactoring stories, whether it's happy stories or sad stories. Please do. I'm quite active on Twitter.